Bismillahirrahmanirrahim. Assalamu alaikum my dear students. Hope you all are fine. Today we are going to do numerical number 6 to 10 on page number 26, and our first numerical is what will be the mass of 2.05 into 10 raised to power 16 molecules of sulfuric acid H2SO4. As we have given number of molecules of sulfuric acid 2.05 into 10 raised to power 16, and we know molar mass of sulfuric acid is 98 gram per mole as we have calculated earlier, and we have to find mass of sulfuric acid. As we have the formula, number of molecules of sulfuric acid is equal to mass of sulfuric acid over molar mass of sulfuric acid multiplied by Avogadro number. So we will put the values of number of molecules, molar mass and Avogadro number, and we have to find mass of sulfuric acid. So molar mass of sulfuric acid is divided on right hand side. So when we shift it to left hand side, it will be multiplied with number of molecules. As Avogadro number is multiplied on right hand side, so when we will shift it towards left hand side, it will be divided. So we will get mass of sulfuric acid is equal to 2.05 into 10 raised to power 16 multiplied by 98 divided by 6.02 into 10 raised to power 23. By doing these calculation, we will get mass of sulfuric acid that is equal to 3.32 into 10 raised to power 4 gram. Numerical number 7 is how many atoms are required to prepare 60 gram of nitric acid HNO3. As we have given mass of nitric acid in this statement is 60 gram, and we know molar mass of nitric acid is 63 gram per mole, which can be calculated by number of atom multiplied by atomic mass plus number of second atom multiplied by atomic mass plus number of third atom and multiplied by its atomic mass. So we will get 63 gram per mole. We have to calculate number of atoms of nitric acid. As we have the formula that number of molecules of nitric acid is equal to mass of nitric acid over molar mass of nitric acid into Avogadro number. When we put all the values in this formula, mass of nitric acid is 60, molar mass of nitric acid is 63, and Avogadro number is 6.02 into 10 raised to power 23. We will get 0.95 into 6.02 into 10 raised to power 23, and at the end we will get number of molecules of nitric acid, which are 5.73 into 10 raised to power 23 molecules. As one molecule of nitric acid contain atoms 5, 1 hydrogen, 1 nitrogen and 3 oxygen. Total number of atoms are 5. So we will multiply 5.73 into 10 raised to power 23 with 5 to get 5.73 into 10 raised to power 23 molecules contain number of atoms. So we will get 28.5 into 10 raised to power 23. When we move this decimal point from 8 to 2, it will become 2.85 into 10 raised to power 24 atoms. Our next numerical is how many ions of sodium and chloride ion will be present in 30 gram of sodium chloride. Here we have 30 gram of sodium chloride, and we know molar mass of sodium chloride is 58.5 gram per mole. What we have to find is number of ions, number of sodium ion and number of chloride ions. We can calculate number of formula units of sodium chloride by the formula mass of sodium chloride over molar mass of sodium chloride multiplied by Avogadro number. So we will put the values and we will get 3.08 into 10 raised to power 23 formula units. As one formula unit of sodium chloride contain number of sodium ions, that is 1. So 3.08 into 10 raised to power 23 formula unit of sodium chloride contain number of sodium ions will be 1 multiplied by 3.08 into 10 raised to power 23, and we will get 3.08 into 10 raised to power 23 ions of sodium ions are present in 3.08 into 10 raised to power 23 formula units of sodium chloride. And we knew that in sodium chloride, number of sodium ions is equal to number of chloride ions. So the number of chloride ions will also be 3.08 into 10 raised to power 23. So total number of sodium ion and chloride ion will be 6.16 into 10 raised to power 23 ions. Next statement is how many molecules of hydrogen chloride will be required to have 10 grams of it. As we have given mass of hydrogen chloride is 10 gram and we know molar mass of hydrogen chloride is 36.5. So we have to find number of molecules of hydrogen chloride. And the formula for finding number of molecules is same, given mass over molar mass multiplied by Avogadro number. We will put the values of given mass, that is 10, molar mass, that is 36.5, and Avogadro number, that is 6.02 into 10 raised to power 23. When we solve this, we will get 1.64 into 10 raised to power 23 molecules. So, number of molecules of HCl is 1.64 into 10 raised to power 23. Now, last numerical is how many grams of magnesium will have the same number of atoms as 6 grams of carbon have. As we have given mass of carbon, that is 6 gram, and atomic mass of carbon is 12 gram per mole. We have to find mass of magnesium. We can calculate number of moles of carbon by the formula mass of carbon over molar mass of carbon. So we will get 0.5 mole. So number of moles of carbon are 0.5. Number of carbon atoms will be calculated by number of moles multiplied by Avogadro number. And we have 0.5 moles. So number of carbon atoms will be 0.5 multiplied by 6.02 into 10 raised to power 23 atoms. And we will get 3.01 into 10 raised to power 23 atoms. So these are the number of carbon atoms in 0.5 moles, which is 3.01 into 10 raised to power 23. As the number of atoms of magnesium and carbon are same, so we can say that their number of moles are also same or equal. So we can use the formula number of atoms of magnesium is equal to given mass of magnesium over molar mass of magnesium multiplied by Avogadro number to find mass of magnesium. We will put the value of number of atom, that is 3.01 into 10 raised to power 23. Mass we have to find over molar mass of magnesium multiplied by 6.02 into 10 raised to power 23. As we know, molar mass of magnesium is 24. So we will get 3.01 into 10 raised to power 23 multiplied by 24 over 6.02 into 10 raised to power 23. So we will get 12 gram. So mass of magnesium is 12 gram. 12 gram of magnesium will have the same number of atoms as 6 gram of carbon. That's all for today. You have to do these 5 numericals on your folders and do practice. Allah Hafiz.